Okay, right? So let's complete that exercise first. Okay, so let's complete. Wait. Okay, so till now we have covered distillation of pH of weak acid, weak base. Yeah, right, everyone? Tell me, right? Okay, pH of weak monobasic acid and pH of weak monoacidic acid. Sorry, monoacidic base. Right? This we have already covered. Right, everyone? I hope that everyone understood this concept. Okay, right? Right? Now, what if we have mixtures, okay, of acid and base, acid, base. Okay, so the first one, let's see, right? Let's see, okay, how to approach it. Okay, first, mixture of two strong acid, actually it's two or more, strong acid or strong base or acid and base, acid and base. Okay, so when we have mixture of two strong acids, right, or two strong base, or one acid, one base, right, what we have to do, what approach do we have to do, right? The approach is simple. Calculate concentration of H plus or concentration of OH minus and find or total concentration, okay, of either H plus or OH minus after neutralization. After neutralization. Okay, right? Then use pH is equal to minus log concentration of H plus. As simple as that, right, everyone? Tell me, right? This is what we have done. Yes or no? Yes or no? Okay, so if we have mixture of two strong acid, right, one strong acid, one strong base, or two strong base, right, it is simple. Just calculate H plus, right? Okay, okay, Ishma, no issues. Okay, so just remove H plus, just calculate H plus or OH minus and utilize or add. Okay, accordingly you'll get the resultant concentration of H plus and OH minus. Okay, second, weak acid and strong base So if you have weak acid and strong base, what will happen? Okay, if you have weak acid and strong base, right, calculate H plus from weak acid, okay, right, and calculate OH minus from strong base and neutralize. Okay, now this depends on the concentration. If concentration of strong base is very high, then obviously concentration of H plus from weak acid is ignored. Okay, but this is what you have to do, right? So weak acid, strong base, or strong acid or weak base. Sorry, my bad. Right, everyone? Are you getting a point? What you have to do, right? So how to calculate H plus? It is again C alpha, and this you can just see the concentration of strong base. Okay, right? Now this can be used for both weak base and strong acid, right? And strong acid. Okay, okay everyone, tell me, got it? Got this concept? Yes or no? So if you see that, ultimately you have to find H plus concentration, OH mass concentration, and neutralize. Okay. Now, third one is mixture of weak acid, right? Or two weak acid. Two weak acid 1 plus weak acid 2, right? So technically what we have to do, technically just think about this. If we think like this, technically we have to calculate H plus for this one, then H plus for this one, right? As we have done in two strong acids, right? Then V total, add these two, right? And then find total number of moles of H plus by total volume, right everyone? So it will be like this, N total will be N1 from weak base 1 plus N2 from weak base 2, okay? The concentration of H plus total, right, will be N1 plus N2 by V total, right everyone? Right? Okay, but we know that concentration of H plus 1 will be root of Ka1 into C1, and concentration of H plus 2 will be root Ka2 C2, because it is weak acid weak base. Okay, yes or no? Yes or no? So can we do this? Can we do this? Concentration of H plus total will be concentration of H plus from 1 plus concentration of H plus from 2. Can we do this? Tell me. Which is equal to root Ka1C1 plus root Ka2C2. Tell me, can we do this? Yes or no? Yes or no? Tell me, can we do this? Is it correct? Is it correct? If not, then what is the mistake over here? Think about it. Yes, this is wrong. This is wrong, right? Why this is wrong? So the answer is in this C, right? This is your N total. This is your H total, right? Got it? Now, if you observe this, right? Just observe this. Okay. What is this statement? This statement is this: N1 plus N2 by V total is equal to N1 by V1 plus N2, or it is V1 plus V2. Okay, N2 by V2. Now, don't you think that this is something wrong? Don't you think that this is something wrong? Right? Obviously, it is not right. It is wrong. It is wrong. So never, ever, ever do this. Okay, do not add the concentration of H plus. Okay, got it everyone? Okay, so we will not be having this formula, right? Then what is the formula? I'll tell you the formula. Your job is to prove it, okay? By obviously by taking some approximations, okay? By taking some approximations. Now, the actual formula of concentration of H plus total is equal to root of, overall root of K1, Ka1 C1 plus Ka2 C2, considering that the degree of distillation of both the acids is very small, negligible. So this is your concentration of H plus total. Okay, everyone, tell me, in same way, if we have one acid, two base, right? So if we have two weak base, the concentration of OH minus would be what? Concentration of OH minus, my bad, will be KB1C1 plus KB2, C2, right everyone? Tell me, yes or no? Okay, okay everyone? Now this you can prove, right? But obviously we will prove this at the end of the chapter. Okay, I don't want to spend lots of time because in exam you are just used to solve this, and I have already told you the concept, right? The concept lies in finding total number of moles of H plus divided by total volume, then taking the root and all those things. Okay, okay everyone, tell me. Okay, got it? Got this? Yes or no? Tell me, yes or no? Tell me everyone, yes or no? Just raise your hand. If anyone have any issues, please ask. Okay, no issues. Very good everyone. Right? Very good. So what we have studied till now, which component we have studied, right? If you observe, right? If you observe this mind map, right? Just see this. Okay, right? If you observe this mind map, we have studied weak acid, weak base, right? Sorry, we have studied weak acid, okay, weak base, mixture of weak acid, weak base, right? Weak acid, weak base, mixture of weak acid and weak base. Yes, these two we have covered. Yes or no? Yes or no? Tell me. And obviously we have covered only monobasic and monoacidic, right, electrolytes. Okay, monobasic acid and monoacidic bases, right? Okay, so after this we have to complete salt, right? But salt is of three types. In salt we have three types. We will study three types. Okay, in salt we will study three types in salt itself. Okay, right, depending on the reactants, right? So I guess till this point everyone is clear. I just don't want to get you confused, right? Till this point, tell me, till this point everything is clear, right? Just one weak acid, just one weak base, mixture of two strong acid, two strong base, mixture of strong acid, weak base, mixture of strong base, weak acid, mixture of two weak acid. Okay, till this point everything is clear. Okay, okay, right? So, right, this is now common ion effect we will study in next class. Okay, common ion effect is just like Leach-Chaster principle. Now let's see some problems here. Okay, the degree of distillation of, okay, you already got the answer, but try to solve it. Okay, question one, right? Obviously you can see the answer, but try to solve it everyone. Question number one, illustration, try to solve it. First question you should ask from yourself, what is this component, right? What is this? Weak acid, weak base, strong acid, strong base. You should ask this. Tell me, what is this? NH3, weak acid, weak base, strong acid, strong base. What is this? Message me everyone. Okay, very good everyone. Right? Very good. So it is your weak base, as simple as that. NH3, weak base. Okay. Now, degree of dissociation, you have to calculate alpha. Okay. Right? pH is given, C is given. So we know that alpha is equal to, right, or concentration of H plus. Tell me, pH is given. So what is pH? pH is 10 to the power minus 11. It is concentration of H plus. Right, everyone? It is concentration of H plus. Tell me, yes or no? Okay. Now, this NH3 will accept H plus, right, from water. Okay. It will accept H plus from water to give NH4 plus OH minus. Agree, everyone? This is the reaction, right? That's why it is a weak base. It accepts H plus. It is a Bronston base. Okay. Right? So if concentration of H plus 10 to the minus 11, what is the concentration of OH minus? Tell me. What is the concentration of OH minus? Yes, very good. 10 to the minus 3. Okay. So I can say that 1 mole of NH3 produce 1 mole of OH minus. Okay, everyone? Right? Yes? No, it's not right because it is weak acid, right? So concentration of OH minus will be C alpha. Okay, so C alpha is equal to 10 to minus 3. Got it? And this will be C minus C alpha. Weak acid, that's the thing. That's the concept that you have to remember. Do not get confused between strong acid, strong base and weak acid, weak base. For strong acid, strong base, you can do 1, 1, right? But for weak acid, weak base, it is not the case because it will not dissociate completely. It is your reversible reaction. So it will be C alpha, C alpha. Now, C is given. This you got it. Alpha can you find? Alpha is equal to 10 to minus 3 divided by what? 0.505. Right? So did you get the answer? Tell me. Did you get the answer now? Think about it and let me know. Did you get the answer? Yes? Tell me yes. Right? What's the answer? Right? See? Okay, so the answer is 2 into the power minus 2 or 2%. Okay, now let's solve this question. Question number 2. Everyone, solve question number 2. The pH of 0.05 molar aqueous solution of diethylamine is 12. Okay, calculate Kb. You have to calculate Kb. Okay, right? Now diethylamine. I'll just tell you what is diethylamine. Okay, diethylamine is basically this. C2H5 and C2H5 whole twice NH. So actually it is also a base. It is a weak base. Okay, so it will also react with H2O, right? Because it doesn't matter what it is, right? If it is amine, you just have to do the same thing. It will be C2H5 whole twice NH2 plus. Okay, it will take 1H plus plus OH minus. Right? So this is your reaction. Now tell me, pH is given as 0. pH is given as 12. pH is equal to 12. So concentration of H plus will be how much? 10 to the minus 12. Agree? Agree, everyone? Tell me yes or no. Right? Right, everyone? And what will be the concentration of OH minus? The concentration of OH minus will be 10 to the power minus 14 by concentration of H plus, which is equal to 10 to the power minus 2. Yes, very good. 10 to the power minus 2. Very good, everyone. Okay, very good. So this is what concentration of OH minus, and we know that alpha is equal to, right, root Kb by C. So Kb is equal to C alpha square, right? Agree? Agree, everyone? Right? Or it is equal to C alpha whole square by C. Yes? Agree? And what is C alpha? C alpha is nothing but concentration of OH minus. So it is 10 to the minus 2 whole squared divided by what is C? C is 0.05. That's the answer. Right, everyone? Tell me, right? Anyone have any issue in this? Okay, right? So I guess all of you got the answer. Yes, yes, OS. C alpha is equal to concentration of OH minus only, na? Right? Because see, when you talk about amines, right, it releases OH minus. It takes H plus and releases OH minus. Okay? See the reaction. Right, everyone? Please see the reaction. Right? Now, see this. Right, what I did, it will give you approx value, not exact value. Why? Because see, alpha is 0.2, alpha is 0.2, right? I didn't calculate, okay, that's why I use that. But if you calculate, you'll get alpha is equal to 0.2. Now if alpha is equal to 0.2, can I do that Cv is equal to C alpha square? Tell me, can I do this? No, I cannot do that, right? So since I did not calculate alpha, that's why I did that. But if you calculate, right, and if alpha is 0.2, it is not negligible. It is not negligible with respect to 1. So you cannot use this. You have to use Kb is equal to C alpha square by 1 mass alpha. Okay, right? Okay, got it? Now, if you know the concentration of OH minus, which is C alpha, and if you know C, you can calculate alpha, right? Alpha is equal to C alpha by C. Okay? Okay, so that was question number 2. I hope all of you understood this, right? Okay. Now let's solve pre-reading, or shall we play one Kahoot? Because very less students are there. Tell me everyone what to do. Okay. So let's play one Kahoot. Okay. So it will be a revision Kahoot based on periodic properties. Okay. So it will be a revision Kahoot based on periodic properties. Okay, everyone. Right. It's just for revision because we have around 10-12 minutes left. So the code is 6859183. 6859183. Let's see how many of you revise regularly. That is what I keep saying. Revise, revise, revise. 6859183. 6859183. Okay, Arvind, I'll wait. Don't worry. Right. Please join everyone. Okay, 20 students have joined. Only 20 students have joined. So we'll start the quiz now. Okay, I'll start it. First question. You can join now also. Okay. Metallic character, right? Just think about this. General trend. Always start with general trend. Top to bottom, left to right. Okay. Then think about your order. You should always do like this. Quick, everyone. So only 10 students gave correct answer. So obviously, first group elements, right, are the, tell me, most metallic, right? Because left to right decreases, top to bottom decreases. Okay. So potassium will be most metallic. Then magnesium, aluminium, boron. Boron is, tell me, boron is metalloid, na? The correct order of electronegativity of these. Tell me, correct order of electronegativity of these. This should be easy, everyone. This should be easy. You should not take this much time, okay? Okay, so 7 students are wrong. See, we know that fluorine is highly electronegative. So whenever we have to see the periodic properties, see the trend. Left to right increases because size decreases, right? Top to bottom decreases. So this is in same period, okay, right? But nitrogen phosphorus in group. So we know that fluorine is greater than oxygen, greater than nitrogen, and nitrogen is certainly greater than phosphorus, okay, right? Next. Generally, the first ionization energy increases along a period, but there are some exceptions. The one in which is not an is. Which is not an exception. Think about it, everyone. Yes, sodium and magnesium, na, right? All the three are, see, if you remember the exception, right? Fulfilled or half filled is greater than, right? The ionization energy of fulfilled or half filled is greater than the next one, right? That's why nitrogen is greater than oxygen, right, everyone? Okay. Same with beryllium, boron, and magnesium, aluminium. Okay. Right? I hope all of you remember. Next. Four successive ionization energy of elements are, right? The number of valence electron is number of valence electron. Think about it, everyone. This is easy. Okay, just think about the energies. What I said, sudden change. Okay, see where is the sudden change? Yes, the answer is 3 now. See, right? Because after 3, it has increased like anything from 3,600 to 25,000. So obviously, valence electron is 3. Okay. Which of the following has highest electron gain enthalpy? Tell me, highest electron gain enthalpy. Yes, it is this now, because if you give one electron, right, it will achieve octet configuration. That's why. Got it? Next, the electronic configuration of an atom having maximum difference in first and second ionization energy is. Okay, Imba? Maximum difference between first and second. Think about it. It's very easy. Out of these, which has maximum difference between first and second? Okay, Sherry, no issues. See guys, I just request you to please revise on regular basis. Okay, have a revision plan. These questions would have been very easy if you have revised. Yes, right, because it is from two different orbits, right everyone? Okay, next. Increasing order of electron gain enthalpy is, I hope all of you should remember this. All of you should remember this, right? Increasing order of electron gain enthalpy. Left to right, increases, top to bottom, decreases, exceptions, configuration. Yes, very good, right? Very good. So what you have to see first, what we know focal banabeni, right? Now we know that chlorine is greater than fluorine. So remove fluorine. So ClON we already got. Now in the same way, right, we know that aluminium, right, is less than nitrogen. So just include it. Got it? So simple, right? Okay. Next, two elements whose electronegativities are 1.2 and 3. The bond formed between, right, would be ionic, covalent, coordinate, metallic. Tell me. I hope you remember the electronegativity difference concept. Yes, it is ionic, right? Because the difference is 1.8, right, everyone? Difference is 1.8. Okay, very good. Next, second last question. Now this you can skip, okay? This you can skip.
Playing from desktop KCGQ79U.
Only 5? It is NO and CO2, na? Okay, let's see the podium. Oxidation state. Or same at same oxide like that. Yeah, it was bit like bit confusing, so don't worry about that. Very good, everyone, right? So that's it. I hope it was a nice quick revision for periodic properties. Okay, okay, everyone. Bye, everyone. Please try to solve in-class exercise of 8.2 and homework of 8.1. Okay, till next class. Okay, everyone. Okay, bye, everyone.